the whole world at our feet, watching seasons change. Our roads were lined with adventure, mountains in the way couldn't keep us from the sea. Here we stand open arms. This is home where we are, ever strong in the world that we made.
Yes, sorry for the delay, I just like this piece of music too much. So, welcome and good evening. Welcome to another of my live streams. It's the part 7 of picoCTF, which means we will be again going after the never-ending tasks of picoCTF. So, I've decided to go a little differently today, since it isn't going really too fast, right? So let's do, instead of explaining each and every task in details, like from the ground up, I will try to speed it up a little bit and see if I'm able to solve maybe more than 4 tasks on a live stream. So let's see how that goes. It's going to be funny. I will still be explaining stuff, just know like what's a buffer overflow and like which I tended to get into on every other task which I've done on previous live streams. So let's see how that goes. Now, today's moderator is, well, actually there are 3 people on this live stream today. That's me, myself, and I am both your host and the moderator today, which means that I will be looking at the chat more than usual, so that might kinda spoil my plan to actually go faster with the tasks, because I will have to divide my attention between looking at the left monitor where I have you folks, like, to see if you have any questions. So please also excuse me if I miss any question today. I will try to be looking at the chat more frequently than usual, but you know, like, it might be pretty random in the end. Cool. So let's look at this. And what do I have here? I usually talk about like my moderator's website. So today I'm going to say, I don't know, talk about my Twitter. If you like reading tweets, then, which are, I guess, mostly about funny bears with cameras and about Paged Out, then check out my Twitter. Yeah, there we go. Speaking of Paged Out, we are still looking for articles. This tracker isn't live updated, but we have around 15 articles. The deadline is still close to a month away. It's on 20th of February. It's a soft deadline, but if you want your article to be in the 3rd issue, then I would absolutely recommend sending your article before the deadline. Yeah, so that's it. And if you never saw what Paged Out is, just like check out the 2-3 issues we already have on our website. And in middle March, we will have the 3rd issue available, I believe. Cool. Do you need questions in chat to be forwarded through IRC? No, actually, I think it's best for them to be on YouTube today. I will be looking at both IRC and Discord at the same time. I have them on the same monitor. It's just like I need to turn my head a little more to see Discord as well, and through Discord IRC. So it's fine to just write on YouTube. Where's the blog part? Not fair. Okay. Okay, let's see. Let's do what I always do with my moderators. Yeah, so this is my moderator's blog, and when did they last update it? Oh, actually, I did post something last week, so there you have it. Yeah. You can take a look. It's just like, basically, I haven't posted much technical stuff on my blog, which I feel kind of bad about, because I've been posting, you know, like, there is this event I'm helping with, there's like this book coming out, which I helped with or reviewed or whatever, there is this magazine coming out, which I've helped with or reviewed or written an article for or whatever, there is this CTF coming up, which we are co-organizing or whatever. So at the end of the day, there is not a lot of technical content on my blog anymore, which I feel bad about, because it turned out, well, on one side, I do want to, you know, tell folks what I am up to. On the other hand, like, I did like my technical stuff on my blog, so I decided to try to post more technical stuff which is based on the answers I give to people on like Discord, IRC, or whatever, right? Because I get quite a lot of questions almost every day, I would say, and I usually try to answer them to the best of my technical ability, and there are some cool blog posts, might be some cool blog posts based on that. So there's one of them right there. Okay, let me look through if there are anything interesting going on the chat, and if not, we will jump straight into the challenges today. Please ping me on YouTube chat if you have a question that would be easier for me to spot. Just one question: can we play CTF even if we don't have a single idea about cybersecurity stuff? You can, but especially if you have like programming background or like networking admin, sysadmin background, then yeah, you will be even able to solve some challenges, but you will have to learn like what the CTFs are about after that. So it's fine if you have some other kind of InfoSec background, basically. Well, not really InfoSec, but IT background. The more technical, the better. Usually programmers do pretty well, even if they have like little idea about security. I'm not claiming you will be able to solve challenges which are like, 500 points or 400 points in the old scoring system. I'm saying old because nowadays we use the dynamic scoring system, but you still might be able to help your team and solve something. Yeah, hire a technical writer. That's not necessarily a bad idea. I know some folks did it. Maybe I should too. Cool. So let's do picoCTF stuff. Okay, challenges, problems, and I will be using, by the way, today the Windows terminal for a change, which I've installed the newest update, and it looks pretty cool. I actually like, the retro feeling of it, so it's pretty nice. Okay, so unsolved, solved, unsolved 25. This is lying, like, yeah, absolutely. It's social engineering us into thinking there are only 25 tasks left, but there are more tasks. We have already 66 solved, and yeah, like it's a never-ending story. So I'm going to skip again today the tasks which are related to hearing sound, basically, because I still don't have my setup done, so you folks can hear the sound, and my applications for decoding like SSTV can hear the sound, which means this moonwalk thing is going to be unsolved today as well. Apart from that, okay, let's go with this one. Where do droid logs go? Check out this file. You can also, okay, so this is a reverse engineering challenge solved by 700 people. Let's download it. Let's see what this is about. It's droids 0. Is it about Android, or is it about like there was this Odroid platform, which was an ARM platform basically? No, it's an APK. We did download an APK file. So how do I actually? Okay, let me just change the directories. Oh, I have no idea, absolutely no idea how to. Okay, now it works. Here we go. So yeah, we do have the 0 APK file, which is an APK file, which is like Android package file or whatever it's called, an Android package. And it has it's a zip archive actually, so we can extract it with zip. So I'm just going to extract it with zip, with like 7-zip, and it says like, oh, there are some problems, but it did extract some files anyway. So now we have this Android manifest thingy, classes dex, which usually you go about it like this, but you convert the dex to something which is a Java class file and can be decompiled, so we'll get there in a second. Apart from that, there's some resources file, which I have no idea what is how does it work, because I have almost no knowledge about Android, so this will be fun. I usually solve Android challenges on CTFs by trying to like massage them into running on my Linux, which is, or like an emulator or whatever, or just like statically. So it's going to be quite funny. Okay, let's go to the lib and let's see what's there. There are like a couple of directories, so let's go to one of the directory, and we have lib hello j and I, which would be a Java native interface, I believe, which is basically like this. Like Java is a high-level language, right? But at the end of the day, a lot of libraries need some low-level code as well. So from Java, you can code like basically binaries compiled in C and C++. It's the same with Python, by the way. And that's like you have a native declaration in the Java code, and then you call, you basically jump from Java into native code, which gets executed, you know, like on a CPU without any virtual machine on the stack. And now, actually, I think like ARM processors, some old ARM processors also had Java capabilities. They could execute some kind of Java bytecode, but yeah, like x86 cannot do that. And because we have like several of these, right? Like several architectures, we have like ARM64, this is probably like ARM 32-bit. We have 32-bit x86 and 64-bit x86. We can basically choose and pick which architecture do we prefer. And I'm probably going to go with this one, with a 32-bit. But apart from that, it's wise to take a look which architecture, if any, has symbols. Maybe all of them have, maybe just one has it. So it's worth checking that out. Okay, I do see there is a bug with the tab on this console, which is quite funny. Okay, let's see this. It says it's stripped. So we do not have symbols here like stripped, ipt, and there's like str here. So stripped means no symbols. Let's check a different directory. So let's check the x86, this one, file, lib, and this one is stripped as well. So no like here. Let's take a look at the ARM one maybe. It's probably going to be stripped as well because, well, the file is rather small, also stripped. So let's go to the last one. This one, and like here. No like here, all four of them are stripped. Neither of them has debugging symbols, which means it will be a little harder to reverse engineer, but let's just open this one. Or like Mr. 7F says on chat, where did my desktop go? Okay, here we are. Says on chat, basically like grep to in, so let's try to grep to in. We are going to grep -I for pico, and we're going to do it on this file. And it says it matches, but it didn't output any strings, so let's do strings on it. This and grep -I pico. And where is my... Okay, I think I need to switch to a different terminal because this one is a little buggy. Yeah, I do not think there is the flag directly here. So, yeah. Okay. Do I use Windows subsystem for Linux? No. Well, that's not fully true. I sometimes use it, but I do have a VM with Linux installed, and I prefer it this way because I have... Okay, VSL2 will be just a normal VM, so it will be, you know, full Linux with a full Linux kernel, kind of integrated with the system, right? Now, that's not the case for VSL1, and the things I need from Linux is basically like mounting weird directories, and that kind of stuff is not available in VSL1 because VSL1 only emulates user space. It does not emulate kernel space. There is like a translation API, I would say, or translation layer, if you will. But it just doesn't do what I need it to do. Maybe I will switch to VSL2, but there is no reason for me to change my configuration now because it works. So if I ever have enough time, I will maybe switch to it. Anyway, so let's go to the lib directory again, and I'm going to use this, like, let's do it again. I'm here, this is a Linux this time, and let's do strings on everything which is here, okay, and then grep for pico. And there is like nothing here, but we are in the right spot, as we can see. Like it says picoCTF, it says flag something. That being said, do note that it might be only part of the equation, where the rest of the equation is actually in Java. However, well, we already have this, so let's just like open it in IDA. I'm going to open the 32-bit version in IDA. You can use your interactive disassembler of choice if you prefer Binary Ninja, or you prefer like Gydra,Ghydra, or Ghydra, however you want to call it. Cool. So what do we have here? We have here some functions, right? And what functions are interesting, I have no idea. So these functions are basically, from what I know, it's the interface for Java. So if a Java calls into this, like java.com.hellocmu, like Carnegie Mellon University, I believe, .picoCTF. So, and there are like 5 functions, and then there are like some more functions which I have no idea what they do, and like this one function, like some unscramble, I also don't know what it does. And I guess we are like cooking stuff like paprika, sesame, like basil. Okay, let's jump into one of these functions and take a look what's going on here. Is there anything fun? So I'm going to do, no, not this one, this one. I basically removed the types, so it's a little bit more readable. This is selecting some pointer from some argument array, and it's calling it with like 3 arguments. Then it calls deal on something, then it selects, these are like just functions, like it selects a function or selects an object, object's method, and it calls it with some arguments. I'm guessing it's like just an object. This would be a v-table of the object, and this would be the this pointer of the object, and these would be the arguments. Same here. Then it checks something, then it says like try again, and so on. Okay, I'm bored already. I'm going to press Shift F12 to display all the strings. Where are the strings? There are no strings here. What happened to my strings? I usually get strings here and I can just easily solve it. Not this time. Okay, let's take a look, like randomly go through all the functions. So what does pepper do? Pepper just calls unscramble. What does unscramble do? Unscramble calls another unscramble. Okay, cool. What does this unscramble do? This unscramble does like this thing, which is XOR. XOR, this is like the most important thing here. You ignore, like you can ignore everything. This XOR here probably just solved your task. This actually looks like a standard decoding function for XOR. So you have this part, which is important. You have this part, which is important. And I would guess that if we would write it in some language, it would be like output at the place of I is equal to input at the place of I, or actually to use their own. Sorry about the LCDs blinking. I don't know why. Okay, anyway, so output is equal to key, and then we have I as the position. It might not be I, there is like v5++ here, whatever that is, but it seems to be equal to 5 anyway, so I'm going to just, equal to I anyway, so I'm just going to call it I, and is like length of key is being moduloed by length of key, so it's just, overlap goes to the end of a key, and then from the beginning to the end, and so on, so the like key length. And this is XORed with like whatever is the input, and this is a standard XOR decoding, no magic here. So we know that there will be somewhere there is an XOR key, and maybe, or we have to guess it, and somewhere there is an encrypted message in XOR, if you can call that an encrypted message. So where is our encrypted message? Let's look at the sections. Is there any data section? And there is read-only data. I'm going to take a look at the read-only data. Is there anything which looks super dodgy here? Yes, this looks super dodgy. What is this? I don't know what is this, but it looks dodgy and is being basically... Yeah, it's called here, we have 23 as one argument, and this is like, I'm going to say this is the ciphertext. It might be the key actually, so it's key or ciphertext, so just see. And then we have something more here, which also looks dodgy, and more stuff here, which also looks dodgy, and some stuff here, which also looks dodgy. Okay, that's fine. So how are we going to solve it? Well, we can take a look. Not exist. Is this the key for it? Yeah, it seems to be the key. Let's just like look at the example. Doesn't matter which is which. A4, so this is the, I'm saying this is the key. Because of the modulo, this must be the key. So this is the key. Let's go back here, A4. So this is the key. It says like not exist is a key. Therefore, this is actually the ciphertext. So this is like the encrypted message, like C or like CMSG, whatever you want to call it. I'm guessing this one is going to be another Sorry about that. How do we undefine that? This is going to be like, I'm going to say another encrypted message, and maybe this one is the third encrypted message. I don't know. Okay, so what are we going to do about it? Well, we do have to probably some of this stuff is going to be the a key. So let's just brute force it. To brute force it, I'm going to create a simple script. Like, yeah, this is the moment where on a CTF I would stop reverse engineering and I would just like brute force the hell out of it. It has to be a smart brute force, by the way, but like still, right? I'm not going to spend my time reverse engineering it if I can pretty well guess that this is an XOR encryption. I don't know the key, I don't know the like which data is being decrypted, but it's fine with me, whatever. So what I'm going to do is I'm going to check first here what is the relation between the virtual address and the address in the file, and it's the same, which is perfect with me. So I just load this file into my memory, so that would be a byte array. Open now the file name. What's the file name? That's lib hello jni.so, and as a binary, so read binary. And read. So we just read it, convert it into byte array, and that's fine. Now we have a couple of portions of what I think is data. So let's just call it like, or ciphertext, like MSG. Let's say that, let's just move them here. So first one starts at this address and ends at this address, basically. This is also where the second one starts, so the OX. Okay, and it ends, I would say, here. Yeah, I'm a little worried, like, what is this? Maybe there is, like, some unnamed stuff here, but yeah, there is not unnamed, actually, so I'm actually going to change that. So message B goes to this address. Then we have another one. We could brute force it even more, but I'm just going to play it smartly. Well, I'm going to say it smartly, it's not necessarily smartly. This goes to this address. Okay. If you have any questions on chat, ping me. You have to ping me, otherwise I will probably not notice. And this goes until this address, so let's put it here, and then we have it goes until the end of this section, which is fine with me. So OX1C5C, and yeah, here we go. So these are the messages. Now, where are the potential keys? The potential keys are these strings. So I'm just going to copy paste these strings and just, yeah, let's just do this. I'm pretty sure because of the values, like these values are rather low. I know that the key is going to be a string. How do I know that? Because if you like XOR, for example, A with like H, you're going to get a value which is between 0 and 1F. Okay, between 0 and 1F. And if you'd XOR like A with a capital H, you'd get a value between 20 and 3F. And as you can see, all the values here are in that range. Therefore, yeah, I know that the key is going to be a string if the output data after decoding is an ASCII readable, printable string. So, yeah. Okay, let's just like, we don't need this line, we don't need this line, we do not need this line, and for everything else, let's just do some magic. Okay, yeah, looks good. How do I, is there like a nice trick for me to use here? Probably no. Whatever. I could use a regular expression, but I've heard a funny saying a few days ago that the like plural form of regex is regrets. Okay, now it's fine. Okay, potential, so like key candidates. and that's that. Yeah, we can do this as well because we are nice. Okay, cool. So now it's obviously Python 3 which I'm using, so I also have to do this b. Actually, like in all honesty, it's a byte array of b. Yeah, that's a little more to the point. Okay, and now let's make the identical or XORing functions, like whatever. So cipher text and is it? Yeah, that's fine. And key, like identical function that we saw. So output is going to be I don't know. Let's just make it like this. And for byte in the cipher message, the encrypted message, I want to append to output append. What do I want to append? I want to append b, which is XORed with k, and it's actually, oh, I need to enumerate. I knew I was missing something. Enumerate. Is it how you write enumerate? I think it is. K of I, which is modulo length of k. So we like start at the beginning when we reach the end, and now we return like a byte array of O. So for every k in key candidates, for every c in CMSGs, like encrypted message, print the XOR of is going to produce a lot of garbage on screen, which I absolutely don't care about. It's fine. I could filter it out, but implementing a filtering function takes a couple of minutes, and in this case I will get what, like 100 lines? Not even 100 lines. So whatever. I'm just fine with it. Okay, let's run it on a Linux console, Python 3 ASDF, and let's see if, yeah, here we go, picoCTF, yeah, a moose once bit my sister, and that's it. Yeah, I don't know what it does. Oh, by the way, there's also like this, it is but a scratch. So which one is the correct one? That's a good question. Is there any other else? Let's grab it by pico. So there are three. Well, the first one is obviously not it. Or is it? Let's look if any of the other ones work. It is but a scratch. Is it from like Monty Python or something? Okay, is it this one? It is this one. Perfect. That kinda says that there might be another task which will refer to this file. And if that's the case, I'm just going to store this flag here so that we do not have to do this again. Okay, and that's it. That's how you solve Android challenge without even knowing it's Android, and without looking at any Android specific stuff, and without digging into the code too much. Are there any questions? If there are any questions, please ping me on chat. Let's see if there's anything fun on the chat. Could you please tell us again, where did you take the possible keys from in IDA? Okay, let's look at it again. I basically did two things. Well, first of all, I looked in the strings, and for some reason now the strings show up. Previously they didn't, so I might take them from here. Like everything here is fine. What I actually did is I pressed Ctrl S. Like, you know, you'd usually expect saving to be under Ctrl S, but IDA has this segment table under Ctrl S. So I looked for a section which has initialized read-only data, which is raw data, like read-only data. This section in ELF files. This is very normal ELF file, right? And I jumped there, and like IDA pinpoint the strings to me, and I just copied them. Like the key might not be here. It might be in a different place. That's why using the strings window is actually better. Or actually using, like doing I have a console closed, like doing the strings on the binary and using everything there. If that would fail, what I would do next is I might actually just treat every byte in the binary as a potential key. this produces a lot of output, and I would probably have to write filtering for it. But given that I know the key sizes because they are like in whatever, like here, right? Yeah, here, like we have the key size actually. Or is this the data size? This is the data size, this is the key size. Or I would just look for potential keys, or I would, again, treat every pack of bytes as a potential key, though they would have to meet a certain criteria. Because the key, for all I know, right? I get lucky here, but for all I know, the key was like, for example, only 5 letters of this, or like 6 letters of this word, or whatever, right? But I assumed it's actually the full word. So yeah, it might require some more brute forcing normally, but it's fine here. On the CTF, do you have a script already prepared to brute for XOR? No, I just write everything from scratch. Like, seriously, because it doesn't take long for me, and I would probably spend more time looking for where did I put that script than implementing it. How do you combine symbolic execution with fuzzing? Is it possible you can do a stream that demonstrates how? It's an interesting topic. Could I do a stream about it? I'm not sure. I'm not sure because it would take some time to implement stuff. I might be able to explain it though. So yeah, maybe. I'm going to know the topic, but no, no promises. There are a lot of papers on that, and a lot of presentations on like black hats and so on, so you can look for that. Basically, almost every team on DARPA Grand Challenge, whatever that was called, like Grand Cyber Challenge, DARPA Grants Challenge, Cyber Challenge, yeah, like this one. Look up the solutions from this competition from a couple of years ago, and almost every team did that. Like they took AFL and they took like something else, like Z3 or whatever, and they used it to find bugs. So try to like basically look what they did. I might do a stream on that, but again, no promises. I did note. How can you access Windows files from your Linux VM? This is a feature, like most virtual machines actually have, like VMware or VirtualBox or whatever, actually have a feature which allows you to mount a certain shared directory from the virtual machine. And I actually have most of my drives mounted like that, and I have a set of scripts which, when I like just type l-cmd instead of cmd, it opens the Linux console in the directory I'm currently at. It translates the path from the Windows directory to a Linux directory where it's mounted, so it's pretty convenient actually. I have this on my GitHub, like just look for Ginveil iFace, like interface, iFace, and you'll find it. Symbolic execution usually, Sparky Parrot writes, symbolic execution usually gives us a formula, but it's slow. If the formula changes regarding different input, I'd say it might be too slow for fuzzing, or you have to write a custom solver. Yeah, so speaking of like pros and cons of it, it basically is a different approach. So what it can do for you, like symbolic execution, that kind of stuff, is basically if your fuzzer cannot randomly go through some check, you might be able to derive an equation for that check automatically based on assembly there, and find the solution for that equation, where the solution would be actually an input file which passes that equation, and then feed it to the fuzzer, and the fuzzer would then continue fuzzing through that. So it's basically like you're not using symbolic execution for actual fuzzing, you're using it to help your fuzzer get through blocks. And it is slow, and there are like some complicated problems there. Basically every loop which you have, which is the amount of iterations is based on input, will poses a problem for symbolic execution. And there are like some other problems as well. And it gets really complicated if you get into math equations. Like if you have, for example, if you have a hash, right, and you need to get through a hash, then there is no chance symbolic execution is going to go through that hash. It's not going to find the solution for the equation. And because if it would, that means the hash would be broken, right? Because it would find like a pre-image for the hash. Now, the way around it is actually while fuzzing to pinpoint all the places which use a cryptographically safe hash or a checksum and just comment them out. Yeah. Wasn't DARPA a CGC what made Shellfish create Angur? Yes, that's correct. Okay, cool. I think we can... Sparky Parrots writes that a byte array of b whatever is horrible Python 3. Not really. It's I wouldn't even have to use byte array there. So there's a difference between bytes and between a byte array. A byte array works closer to how bytes type works in Python 3. So in Python 3 I wouldn't have to use that byte array. It's a habit I have from Python 2, but the bytes type in Python 3 would actually work the same, almost same way in the manner I wanted to use it. Not in all manners, but in the manner I wanted to use it. So I wouldn't blame Python 3 on this one, I would blame me. Cool, so let's go for the next challenge. What do we have? Messy malloc. Oh yeah, I didn't want to do this one because it was a heap. Let's do a heap. Messy malloc. So we get, what do we get? Can you take advantage of misused malloc calls? We get a service, we get a source, and we get an netcat address. Okay. So let's start with netcatting there to take a look. I did download both files. Let's start with netcatting to just take a glimpse of what is there. I usually don't do it. I usually netcat somewhere at the end, and then I'm a little like, I feel I wasted time not netcatting earlier, so let's do it now. Okay, commands login, print flag, and logout. And yeah, so we can login, logout, quit, and okay. So I want to login. Enter the length of my username for your username, ASDF. Okay, and for some reason it doesn't like my F. It ate my F already. Whatever, fine. Print flag, give me your flag. Incorrect access code. Okay, so I'm going to log out. Log out. I'm anon, I guess. So I'm going to quit, and okay. So we know what kind of task we are dealing with, and it hang? Yeah, okay, it did it. So now we can look at the actual source code. Have you tried CyberChef web app? No, I don't believe I ever heard about that one. CyberChef. Oh wait, I actually visited it before. No, I did try it. Yes, I did. Probably on some previous picoCTF when I was solving one of the previous CTF. So never mind. I just didn't remember the name. But enter the length smells of House of Force. Let's first check if this isn't a custom malloc implementation. So what do we have here? No, it looks like there's a normal malloc here. Okay, so as you know, if you watched my previous live streams, you know that I have absolutely no idea about heap exploitation techniques, which means if I've done several times heap exploitation in my life, I always was exploiting it blindly without having the idea what I'm doing, which means it takes more time for me, but whatever, let's see if it works. Okay, so starting from main, we have anon user access code. We have a anon username to null. This is like zeroed. Then u is the global variable, and it's set to anon user, which is some kind of a structure. What is it? So versus this, like, it's a user, by the way. Anon user, and u is a pointer to the structure. The structure has a pointer username. It has an array of 16 bytes, which is the access code. and it has like some pointer to files, whatever that is. Okay, that's fine. So we basically create an anonymous user which doesn't have an access code, which doesn't have a username, and you, which is probably the current logged in user, points to it. Then we call menu, and then while forever, we do enter your command, and it says like this is the prompt with the username, and the username is taken from you. We can take a look at this in a second. Then we get a line from standard input, which is fine. We check if it's login, then we jump into login. If it's print flag, we jump here. Logout, we jump here. Quit, we do return 0. Otherwise, we say invalid option and we call menu again, which is fine with us. So if the option wasn't invalid, the menu does not get displayed. Let's take a look at the menu. It doesn't look complicated. It's just like, yeah, what you see is what you get. Then let's look at the get username. Get username. If it's null, it returns anon. This is fine. Otherwise, it returns, if it's not null, it returns the value, which is fine as well. Kind of what I expected to see there. And then we have login print flag. Let's take a look with print flag first. Print flag, it opens the flag file. Then it reads the flag of the flag size, which is 64 bytes, if that matters. I don't think that matters. Then it checks if if access code part 1, the first long, okay, is it 32-bit or is it 64-bit? So file of, it's a 64-bit binary, so a long is 64-bit, meaning it checks the first, well, I could see it here, obviously, but whatever. I needed to check the bitness anyway, so yeah, I will go with that excuse. By the way, if we are in the console, let's actually do checksec on it file of. It says stack canary, no pi, so that's good. That's actually really good. It might help us a lot. No pi means that the binary will be in the known position. ASLR, like space randomization, still applies to the heap, still applies to the stack, still applies to all the libraries, but it does not apply to this binary, which is fine. Okay, and it checks if like the access code is like this thing. It's an ASCII string, like we can see this is an ASCII string. Let's just decode it. So Python, let's use this one. It's Python 2. Okay, so decode hex, and we have to do the little endian root ac, and this is aunt probably. Okay. Oh, root access code. Okay, so fine. This is root access code. I'm going to start nodes this time around. So here are my nodes. And I'm going to just copy this string because it might be important later on to know that the root access code is the magical secret token which gives us access to the flag. If it's an incorrect code, it outputs it to the standard output. Otherwise, it outputs the flag, which is fine. I wonder why does it output it, but okay, whatever. Okay, login and logout. Login, we allocate the size of the user, which is fine. Sometimes there is a bug where like someone by mistake puts a asterisk here. This is a bug which when I was like on my university, I've coded it into some project, and then for 2 weeks I was looking for like, why is my program crashing? Like, oh, I add a printf and it stops crashing, and then I remove the printf and it still crashes. So yeah, that was weird. But that's a typical Heisenberg bug. It's a typical way a heap buffer overflow is shown in your program, but there is no bug of this kind here. It's actually a proper allocation of the proper size. Then we ask for the username, which is fine. And then this is probably just to eat like the new line, which was appended after the length. Then we allocate the user length +1. Okay, this is already looking interesting. So yeah, if this one is like -1 and this one is 1, then it allocates 0, whatever. Let's see if that's important in a second. It might be important actually. When it reads the username. No wait, sorry, it puts the buffer here and then it reads the username. It reads it by using fgets and we pass the integer here. Now, a good question is, hey, does fgets actually take a signed value or an unsigned value? Because if this takes an unsigned value, then this potential -1, which we would put here, would be casted into a really large unsigned number. Okay, so let's actually take a look. Man fgets. What does fgets take? Fgets takes, and there goes that idea. No type mismatch, no signess mismatch, no integer overflow, but whatever. Okay, and then it looks for a new line. And if it's not null, then it replaces it with a 0. The fun part here is that if we do not put a new line sign, the string will not be 0 terminated, which is something to keep in mind. Okay, and then that's basically it. So due to this, we might have an information leak after the username. What's after the username? Oh, I have no idea what's after the username. Perfect. Okay, then we have a logout. And what do we have in the logout? The username is, the user is set to this. If it's equal to an anonymous user, it just returns -1 and does nothing. Otherwise, it frees it frees the username, and then it sets it to an anonymous user, which is fine. Okay, where's the bug? So, like, really, fgets, how come this isn't size t? That's really weird. Okay, what do we do about it? We cannot get it to be Okay, it's quite easy to give it a super large value so that mallocs return 0, but this will not give us anything, so we should drop that idea. We can leak information which is on the heap. Does the flag ever get saved to the heap? Where's the flag? The flag is being loaded into a local buffer which is on the stack, so that's not the same place as the heap. It might get like on the somewhere in the memory on like some buffer, a buffer basically for the file. Would that be on heap? Maybe. Okay, do we actually does this file is not stripped? We have debug info, which is good, so we can just debug it. Okay, cool, let's run it. So, okay, we are running it now. Let's stop running it. Let's run it under GDB. And let's break at, where are we going to break? We're going to break at, let's break that print flag, because why not? Or like fgets. Like after fgets, where are we going to break at? Let's break at fprintf. Yeah. Okay, run. What? Why did you already break? Whatever. Nah, just continue. Anon, okay, and what we want to do is we want to print flag. Okay, please make sure flag exists. Yeah, it doesn't exist, so let's just make it touch flag, or actually like echo my flag. Okay, let's do it again. Okay, run, whatever, print flag. Okay, and it says incorrect access code, which is absolutely fine with me. Now, let's see, where are we? Frame, where? We are at like fprintf, but I want to switch to this, so frame 1. Okay, and in the frame 1, what I'm interested in is basically where is f located. Like this pointer. It's on the stack, like the pointer itself is on the stack, but where is it pointing to? So x, then x, I guess, like f. It's somewhere, yeah, like that's a pretty weird number. It's like, let's open the binary in IDA, but I'm pretty sure that's like in the BRK section or something like that. So just after the binary. Oh, it's a 64-bit. Okay, so let's just go here. Okay, right, like it already. What I'm interested in is this. Yeah, like we end the binary around here, as you can see, so that like 602108, and this address is like super close to it. It's like just after it. So that means that the heap is actually just after the main binary, which is a pretty typical thing. It's like usually the heap starts there and then like goes randomly somewhere in memory. So that's fine. Info prog maps. Yeah, we can take a look. Why not? Yeah, but that totally failed. Let's do it once more. Yeah, this is the heap, and it's basically binary ends, the heap starts, but it's pretty weird. Usually it's not like that. Usually the heap is more randomized, but they probably done something to this binary, so it does not use the modern methods, or is my Ubuntu and on the server it will behave differently, but it should be fine anyway. So now what I'm interested in basically is where like, was the flag written or read anywhere on the heap? Because it might have been. Like, where is the flag loaded? The flag is loaded first and then the checks are going on. Because if it's on the heap, then we can try to be funny about it and we can maybe try to leak it off the heap without spending much time on it. So what I'm going to do is I'm going to just like, I'm going to wish that I've learned like pound.dbg or whatever, but I didn't. So I'm going to do, you know, this and take a look on the heap. So I'm just going to go through the heap. Nothing fun here. There's like print flag. No, that's fine. Is there? Yeah. We have the flag on there. So this is the flag from the file, and it is on the heap, which means maybe we can massage the heap in a way where we would have basically like just before the flag, what we would have is the username. And we would make sure that we actually do not send the end of line, and then maybe it will just output the flag for us. That would be pretty nice. So yeah, we could do GDB search, why not? But I didn't know it existed, but don't tell anyone. Cool. Okay, so what do we have to do to get an allocation close to it? Can we even get an allocation close to it? If we would... well, one way to find out. Let's actually not. Let's not restart it. Let's just go. So Anon, I'm going to log in. Just okay. What is this like? Why is this printf? Oh, I'm going to change my like disable 1, and I'm going to change my breakpoint to something else. I'm going to just set it in login print flag. Print flag is fine. Maybe after f gets, so here basically on this line I'm going to set the breakpoint here. So break with this address. Can you see it? Yeah, you can see it. Okay. And then we can continue. Now give me the options, okay, and I want to log in. And the problem is that if I log in now, okay, I have to actually use the maximum. Yeah, I have to use the maximum fgets no, but it will still end my stream with a 0. So that's no, there is no bug. Because fgets gets it right, it's not like str n copy. So there is no bug here. I was mistaken by that. fgets will actually introduce a 0 byte even there. So I was thinking of the wrong approach, I think. Cool, so what do we do else in that case if that doesn't really leak anything? I can still check it because why not, I mean. Oh right, there is no maximum length. What do I do to... Oh, there's a funny behavior of malloc, by the way. Even if you allocate 0 bytes, malloc will still return a buffer which is of a certain size, which will be a little annoying for us. And it's a 64 bits, so that's also annoying for us. I'm thinking about the, like, if there are any headers which might be... So after the file is closed, this is left on the heap, and this is in an unallocated space. So if we allocate there again, we still might be able to print it. So if we do a malloc and an fgets of 0, then it will... Okay, so we have to give 0... Yeah, okay, let's do it like this. Length is 0, and it says fgets failed, and it exited. Because they actually check it. Why do they check it? It's pretty smart. Zero-sized alloc is implementation defined. No, it's not. Zero-size alloc is guaranteed to return a non-null value by the standard. Which is like, I'm not disagreeing that there were implementations which would return null, but they should not return the null. This is, oh, by the way, what I'm saying about is C++. And C, you're right. In C++, however, it's guaranteed that malloc of 0 will return an address on a heap. So we are both right, like the ideal, like, consensus, right? Cool. So what do you do here? Okay, so what you're proposing is that there are no free, so... Oh, so you're actually proposing we attempt to override the access code somehow. There are frees, which is good that there are frees actually. But what's the order of the frees? So it will be, it's basically like this. If you allocate something, like 2 things, and then deallocate them, and then you reallocate them, you are almost guaranteed in most heap implementations to get the same addresses, which means we have to basically allocate the username of the size of the structure minus 1. The size of the structure would be what, 8 plus 8 plus access code length is 16 minus 1, so that would be what, 31, right? Okay, so we allocate the username of 31, which is fine, and then we put whatever, we put the access code, and we put more whatevers. Then we log out, and we log in again, and it might actually, that might be enough. Let's try it. Okay, so we log in, and we log in as 31 bytes because it will allocate 32, right? Because it's a malloc plus 1. Okay, so this allocates 32 bytes. And then we enter our username, and our username is going to be like 8 whatevers then the access code. Where are my notes? my nodes are here. So 8 whatevers, xxxx, then the access code, then like 7 whatever more. We do not have to even put that, but doesn't matter, but let's do it. Okay, and I'm that. Now we log out, and now we log in again, and we use the length of username, doesn't matter anymore, like, I don't know. Okay, and then we print flag. And we get my flag. Okay, so yeah, the idea is good. Let's see if it actually works on the server. If you got lost in there, I will explain it in a second. Why does it work, right? And see, I think this is this task. Okay, so we log in. We put 31 here. Or we put this one as the username. Then we log out. We log in. We put whatever. ASDF, and we do print flag, and we get the flag. Okay, perfect. It worked. Yeah, so it's a little easier than I thought, thankfully. Thank you for the chat for like some hints there. I did look at the chat. Okay, now let's explain it, because so I'm actually let's explain it so I understand what just happened. The idea is basically that let's use notes for this. Basically, when we log in, right, what is happening is there go 2 mallocs happening. Let's look at login. Yeah, there is this malloc at the beginning, which is basically a malloc of 32, because that's the size of that structure. And then we enter the name, whatever, and we get another malloc, right? And this is the username. And this is like we control this, so this is xyz plus 1. And now when we log out, it does freeing, and the freeing is in reverse order. They like, as you can see, they went like, usually, and it's like in a good taste to first deallocate all the fields and then deallocate the structure, but they went out of their way, which I did notice. I did not note on stream, but I did notice that it's pretty weird what they have going on here, but they like save it in a temporary variable, then they deallocate this, and at the end they deallocate this. Usually you do it the other way around, right? So they basically what we get is we get to freeze, and which means that this gets deallocated and this gets reallocated. Sorry, and this gets the other thing gets deallocated. Now, if we actually run through this code, we run this malloc, we will get some address like ABCD, let's call it 00, because why not? So U is going to be equal this address, OX, right? It doesn't matter what address it is, it absolutely does not matter. Then we get to this malloc, and oh, by the way, this is an allocation of 32 bytes. We get here and we set the XYZ to 31, meaning 31 plus 1 is 32. Even if we would set it like to 17, that doesn't matter, it would still be aligned to 32 due to how the implementation works on Linux, if I remember correctly. So we do username, and we get a different one, like, I don't know, 898900, and it's another allocation. They would be close to each other in memory. It doesn't really matter because we are the layout doesn't matter. What matters is what happens soon. Basically, when we free it, we first free this one, so this address. It goes to a cache of a sorts, like a bucket and a cache, which means that this memory, the buffer of 32 bytes has just been freed, and the memory there is already fragmented. So what you want to do when the next request for allocating the same amount of memory or like a similar amount of memory, what you want to do, you do not want to get a new address somewhere else in memory, a new buffer somewhere else in memory. You want to reuse the old one because this decreases the fragmentation of the memory. And it's also faster, actually. So yeah, so like the cache gets this address first, right? And then we do a free of the user, so this gets allocated and it's also put at the cache. Usually it's put in front, it might be put at the back, but usually, let's assume it's usually put in front. Now, if you are dealing with a secure allocator, the cache would actually not be a cache, it would be the other way around, it would be a quarantine. It would not give you the same addresses until way later on in the program. just because of like to make exploitation of this kind of bugs harder. But this is the normal allocator. This is not a secure allocator. So yeah, so now we have it in cache and we did log out. And now we log in again. And when we call the malloc, malloc will not look for a new address in memory, it will look in the cache. Hey, do I have a buffer of 32 bytes handy in the cache? Oh yeah, I have this one. So it just grabs it and it puts it here. And then like we get to the username and we this time said like we want a way larger buffer, so it actually like said that yeah, I have a larger buffer and it's located at like a totally different address. Like yeah, and this would be probably 8, yeah. Now, because neither in logout nor in login there are any memset, there is no initialization of the allocated structure. That means that whatever is in memory gets basically fills out these fields. These fields should be zeroed, should be like the whole object in memory should be zeroed out, but it's not. So, which means that if we put our username as this, now this thing fills out this structure. So if we have the structure, right, it means that username is equal to the x's, right? So x is what, like 71, so we get a pointer which is invalid. It's basically an invalid pointer, but whatever. Then we have this, which is equal to root access code without the 0 at the end, in all honesty, but whatever. And we have this, which is like 72 with a 0 at the beginning. Yeah. And then we do print flag, and print flag goes here, and the print flag basically says, hey, like the code is fine, like because it was in memory. So this is what happened. We basically made it reuse a buffer which was which we already pre-filled with data, and yeah, and that's basically it. Isn't the heap allocator supposed to have some sort of randomness? There are multiple implementations of heap allocator. If you look in Android, there are like at least 2, maybe even more. Like Firefox had its own allocator. I'm pretty sure Chrome also has another allocator. There are like allocators which you use when fuzzing because they try to detect corruption even if they lose performance. Then there are like secure allocators which do all kinds of checks and do the quarantines and have a lot of randomness even if they fragment the memory more. Then it's still more secure at the end of the day. So there are different kinds of memory allocators, and if you look at embedded stuff like Arduino or whatever, there are even more different various heap implementations there. So is this a use after free? No, this is an uninitialized variables, basically. The bug here is that they did not initialize the variables. It's not a use after free. Yeah, so what about anti-heap? I have no idea what Windows uses nowadays. Okay, so... Okay, we're going to jump into the C++ standards in a second. I see that Marco says that the... Oh, did I put it in... Did I actually claim the flag? Let's see if I did. Yeah, I did. Okay, perfect. That's good. So, we're going to jump to malloc. Okay, malloc. What does malloc return? Oh, by the way, there is this calloc thingy. And the calloc thingy is nice enough to zero the memory for us. This is like the only function from this stuff here which actually zeros the... well, I'm not sure about this one. I never heard about this one. What is this? But calloc actually zeros memory for us. Otherwise, you have to memset it. Like memset it, b0 it, whatever your API of choice is. Okay, return value for malloc. Malloc calloc function returns a pointer to allocated memory which is aligned. On error returns null. Null may be returned on a successful call with 0. Okay, so this is what Marco was referring to. And now what I was referring to was the C++ standard. Let's jump into the C++ standard. C++, I'm pretty sure I have like some drafts on my disk. C++ C++, yeah, some new draft. Let's go to here. Malloc. Oh, yeah, and here we are. The intent to have new operation, okay, implementable by calling malloc, calloc, so the rules are the same. C++ differs from C in requiring a 0 request to return a non-null pointer. I actually interpreted that malloc will return a non-null pointer, not only new, but I guess I might be mistaken here. It might be only referring to new. It might not be referring to malloc itself. So Marco might be actually right here. So points to Marco. Cool. What else do you say? Love your video, sir. Thank you. Glad to have you here. How would you do it without access to source code? Without access to source code, I would just look at the binary. It doesn't matter at the end of the day. It just takes a little more time to reverse it, but yeah. Without access to source code and binary. Yeah, this would be tricky. It would be really tricky. It's basically a guessing game at that point. I would try to somehow find the vulnerability, but like try to guess maybe sizes of structure, try various structures and see if there's any uninitialized data, try standard buffer overflows and some other stuff, and after half an hour of trying, I would just say it's a guessy task, call it a day and write a bad review on CTF time for the CTF. Okay, we can close this, we can close this. Are there any other questions? First line of description in malloc-man. Let's take a look again. I'm quite curious actually. Like, I really love C and C++ and like all other languages because like you have been using like malloc your whole life, and then like you turn out, hey, there's like this weird behavior which you understood differently, so it's like, you know, another detail you learn. I really enjoyed that. Second line of description. The memory is not initialized. If size is 0, then malloc returns either, okay, or a unique pointer. Fair enough. Fair enough. Cool. Okay, where did my browser go? Here we go. Are there any other questions? I don't think so. So yeah, shout out to KrzaQ Chant. I think what he written kind of gave me an idea what this task might be about. Which terminal do you use on Windows? I use the default one. As you saw at the beginning of the stream, I tried to use this Windows terminal, which is still beta, I guess, but it kind of buggy still. We'll get there. Okay. What do we do now? We do Vault Door 5 for 300 points. Still unsolved. Let's do it. It was a Java crack me, or like reverse engineering challenge. Before, let's see what it is now. It's enter password. It adds the picoCTF stuff to it. There's a base64 thingy here. Base64 is the best encryption. That's what the comment says, doesn't it? Like base 8, base 16, but this is base 64, which is like 8 times stronger, right? Right? Well, that's what my twin brother minion 2415 says anyway. Obviously, base 64 is not an encryption, it's just an encoding scheme, but you know that. So URL encode, URL encoding, and they encode. What do they encode? They encode everything in URL encoding. So they check the password by doing URL encoding. Okay, we are using totally the CyberChef thingy you showed me. This is something we should be able to solve with it. CyberChef, was it? Okay, so we have, this is our input. This is our input. I'm just guessing how to use this website. I have no idea. Please bear with me. Okay. Okay, perfect. Now the recipe. We do what's first here? We URL encoded. So this is first base 64 encoded, obviously. Like this is not URL encoding. And then it's URL encoded. So what we do from base. Okay, how do we do? From base. And we get the URL encoding here as expected. So now we do from URL decode. This is pretty standard stuff. And yeah, and we have a flag. That's it. Yeah, this website is absolutely amazing. CyberChef, just look it up. Like 2 drag and drops and we're home. That's cool. That's really cool. Okay. So the 300 points in 3.7 seconds. A little longer maybe, but whatever. Submit. Unless we got it wrong. No, we got it right. So that's it. Cool. I don't believe there will be any questions about this. Just like the code. 2 standard decodings. Well, 2 standard encodings, obviously. Waves over lambda. Can you decrypt it? A lot of substitution encryption. We made a lot. Yeah, so as I mentioned before, like doing substitution encryptions a lot, if it's done like always on bytes, equals to just doing 1 substitution encryption. Let's take a look. I'm a little worried because it's like this. I always implement this stuff on my own, and on live streams I always try to show how to use some fancy website to do it, and I always fail, and it always takes me like half an hour to solve an easy task, but let's just try it. Okay, so we connect to it and we get yeah, this, and we do it. Okay, so it changes each time, which means we probably cannot really decrypt it with some website. Hey, can this actually do encryption encoding? Does substitute. So let's remove this. No, we have to actually give it the substitute. So like substitute auto decrypt. Monoalphabetic, yeah, this thing. Let's just give it the monoalphabetic thingy. Language English, yeah, decrypt automatically. And let's see if this works. There's another website for this, which I always forget. Congrats, here is flag, frequency is, yeah, and this is, yeah, okay, so that's it, like the website decoded it for us. I can tell you how to do it without the website, but I mean, on a CTF you would use a website anyway. If you are interested how to do it without a website, you need basically a longer text, and then you do a histogram of it. A histogram is basically a table which says letter F was in the text like 200 times, letter L was in the text like 250 times, a space was 300 times, and like letter A was in the text 24 times. And then each language actually has a certain statistical probability of a given letter to be there. And apart from that, there's also a statistical probability of one letter being after another letter. So if you take that histogram and you take a histogram of an English language, you see which letters kinda match which other letters, and that's usually enough to solve it. So it's some coding, but apart from that, okay. So do I need to actually like type it in? If you have never implemented something like that before, do it. Frequency, I'm pretty sure it's lowercase, by the way, is cover lambda. VLHNHNASSTM, and that's obviously picoCTF. It should be fine, right? Tell me it's fine. It's not fine. Why is it not fine? It might have not gotten the end correctly, so we can actually decrypt it for... Which one did we decrypt? Let's go back. Let's just actually... a C over lambda. Thank you, Kava or Sava. You're probably... Alright. Yeah, that's it. Thank you, that was a typo. Thank you. Well done on chat for spotting this one. It will take me another 15 minutes to figure it out, so I'm really grateful. And in the 15 minutes we have, we can solve another challenge. So is there anything on the chat? You can use quadram or trigram. It's more efficient with less data. Okay, I never used like like tuples of 4 letters or 3 letters before. Well, maybe 3 letters, yeah. But again, I'm not a crypto guy in our team, so I just do this for fun. It was a task which would be, if it would be on the real CTF, it would be 100 points, I guess. So as you know, it's like not the, or maybe even 200 points. Well, okay, it would be back in the days. Currently, when you just use a website, it would be 50 points, but yeah, back in the days. Joel says that on the left of the screen there is a flag which I can just copy on the left of the screen. Here. Facepalm. Thank you, Joel. I did not notice it. Okay, so what do we have here? I want to be a rock star. This was what? This was general skills. So there's some weird language last time, right? What else do we have? Okay, we have a binary and an image. Again, we have web exploitation. We didn't do web exploitation. Someone has bypassed the login before and now it's being strengthened. Let's do web. Okay, so what was it before? It was like an SQL injection or something like that? List of the Irish, okay. But we cannot really jump anywhere else. There is an admin login, there is support close menu, so support. Hi, I tried adding my favorite Irish person, but I keep getting SQL error, so I guess like it's a hint. That's because this is funny. This is a nice one. Why is this site so trash? Okay. And then we have admin login. Oh, nice. Thank you. Are you trying to disclose my password here? Let's take a look. Why is it so big? Oh, because I probably have it. Okay, that's fine. Is there anything fun here? Nothing fun, just the login, just the password. It says something about SQL. I'm just going to go with, you know, the usual standard. Well, first I'm going to actually create a directory for this task. Okay, so I'm going to use a standard SQL injection thingy. Oh, well, let's take a look if there's anything fun in the cookies, because it might be another of these challenges where actually we have like a debug cookie or something like that, which we have to set. But it doesn't seem like just Google Analytics stuff. Cool. Yeah, I'll just go with the standard, like or 1 equals 1 and then and a space at the end. Maybe this one, or maybe just like 1, or let's see if any of these works. SQLi detected. Is there anything more interesting here? No, there is not. Okay, here, never. Thank you. That's good that it's detected. Still detected. Login failed. Okay. So how does it... Is this like some kind of a blind? Let's do this. Let's do just some login failed. Okay, what if we do select? If I can type select. What if we do select here and A here? Login failed. Okay. What if we do a space? Select ASDF A. It says login failed. What about doing this? Login failed. Okay, that's fun. What if we do a quote? And here ASDF. That's so. Why does it? How come does it fail? Like, what does it detect but it fails? Okay, like this with a space at the end, maybe? No. I'm quite curious. Like, what part of this is detected, and is it like an actual error? Login failed. Let's do this. Okay, so here's my hypothesis. I think that what we actually get is we get an exception, an SQL exception, and if it detects an SQL exception, it says like, hey, like SQL detected, so just, yeah, like, go away. Which means we can try this. Well, this won't work. We can try this. I'm going to put A here. SQL I detected. Why? Or maybe it's just detecting like or thingy. Yeah, that's a funny one. I kind of expected it, but seriously, is there like some debug equals true or something? Login failed. Yeah, is there anything else fun on this page? Yeah, now I noticed the joke we are giving. No, so I think it's just like somewhat of a blind. It searches for a... Really? No, it doesn't seem to search for it. It seems to detect some phrases, but this means actually they're... okay, so let's try it like this. Select one. And let's see what happens now. It says login failed. Does it mean that the select gets executed or it doesn't get executed? I don't know. What do we do so that it actually logs us in? Okay, so let's go back to this one. My take on it is it's being detected, but it may, well, because it's being detected, it's not really being being executed. So let's try a couple of variants of it. I'm going to change random stuff. I'm going to change 1 to 2. I'm going to change OR to OR. I'm going to add another space here and another space here. I'm going to change this space into something like this and the other space into the something like this again. And I'm going to get, well, let's maybe leave it like that. And let's see if any of this works. Detected, so that didn't work. Well, that was the old one anyway. Let's see. Detected. Then we get this one. Detected. Then we get this one. Maybe we shouldn't use OR. Detected, and maybe this one with... yeah. Detect. Okay. Yeah. So, okay. Maybe just the OR is the problem. If the OR is a problem, then we can go for a different thing. What would we go for? Let's go for an AND. And 1 equals 1. This will not work, by the way. Like, I mean, this will not exploit it, but what I'm going after is basically trying to get it not to crash on me. Login failed. Okay, it doesn't crash on me. Now I'm going to remove, like, change this to X. And if it crashes, the website crashes on me, that means that the query gets executed. And it crashes. Yes, so the query gets executed, which is a great thing. And if it gets executed, then we can work with it. How do we work with it? Now it basically does, like the query is like this. It either does something like this, select like everything from users where user is equal to whatever we type and password is equal to whatever we type, right? Like I'm not sure, like this might be password, might be pass WD, whatever, right? So that's one way to do it. Another way to do it is to get the password from users where the user is like this, and then it returns a password which is then compared to then after this code there's like if whatever the user provided password, so user pass is equal to like SQL password which we returned, then we log in. I'm guessing is this kind of query, since this would be sane and secure, so I'm, well, not really sane. There are some issues with it, but it might be actually, yeah. So I see you're thinking about doing a union select, which is one of the ideas to do. Yeah, we could do a union select. What else could we do here instead of a union select? I'm wondering if we could do something except for or and in such a query. We could go probably full blind here, though we do not really have a way to detect a bit, so maybe not a full blind. And I think we only have to log in, we do not have to leak the database. Okay, what you're suggesting is okay, I think we can go with union select and figure out what's going on. So let's do this and 1 equals 2, which is obviously going to be false, sorry. Union, yeah, that's exactly how we write union. Select 1, I guess, and then this. I have no idea how many fields there are, so we'll figure it out. I put this here, and here I'm putting 1. And it says SQL I detected, so it detects something. What does it detect? Does it detect union? Let's see what it detects. Yeah, it detects union. It doesn't like union for some reason. Why do you not union? Can I do something like this then? Okay, we cannot use union. Yeah, it gets funnier in that case. Does it detect it in the password as well? Does it? No, this. Manage password. I don't want to manage my passwords. I want you to go away. Yeah, okay. It's in both fields. So we cannot use a union. What else could we do? We could do... Okay, what if we do something like this? We put the user as admin, and then end. So admin I'm pretty sure exists, right? And then we end it. Yeah, that's it. Okay, perfect. I see Marco proposes to do union inside a union, which would work if they would try to fix the query. That's a good idea, which Marco has. It's basically like if they would do union, like something like Esther replace whatever language, replace like some string, let's say it's PHP. Union with like nothing, right? The usual way to bypass it is you pass union, and this union would be replaced with nothing. So you put inside the union another union. Like I'm going to do capital, but it's like less than lowercase. So it would remove this one, and what remains is still a union. But they do not try to fix it; they actually kill it, which is the proper way to do it. Never try to fix malicious input, because it will make your thing bypassable. So yeah, we went with this one. The idea here is that they actually have something like this kind of query. You kind of have to guess the query which they have, but there are limited options basically. And we put this here. This is by the way a comment if you're wondering. So it means that there is nothing else. So it selected whatever they needed from users where the user is admin without any further checking other stuff. So yeah, that's it. Okay, Octuor says that they think that there's a hidden input called debug in the source. Really, and I missed it as usual. So admin login. I did glimpse through this one, but yeah, there is obviously. Yeah, thank you for noting it. I did miss it. As you can see, we could actually solve it without actually knowing what is there. You might think it's guessing, like assuming that the debug functionality would not be there. You might assume it's guessing, but this is a pretty standard query, so I wouldn't say it's guessing. It's not guessing. It's like knowledge related to this specific field. Cool. We have 20 minutes. We have a forensics unsolved, so we can do it, I think. Unless there are any questions. No, there aren't. Cool. Then I see you had like the chat. Thank you, folks. Like you had really a lot of amazing idea. And the admin one was called, I see, by Metans. Metans, shout out to you. Congratulations for guessing the solution before I reached it, or like knowing the solution, or like just solving it. I think you're the only person who noted how to like the final solution. So well done. What's the one with less solves? Yeah, Marco, I'm not sure what you mean. Anyway, I will go for this one, for the WebNet 0. So we have, yeah, a forensics, we get a packet capture, so a pickup and a key. We got a key, that's weird. What kind of key do we get? Let's see. This is, I don't know, is a private key, probably for like a session or something. Okay. That's funny that they gave us a key, but okay, that's fine. The challenge with less solves. There are a lot of challenges with less solves, probably. Okay, let's open the Wireshark on it. And now they gave us the key, right? So if they gave us the key, then we have to go to, where is it? I always forget. Edit, preferences, protocols, and then to TLS or SSL, depending on which Wireshark do you have. I think I have a TLS one, the newer one. Yeah, TLS, so it's this one. And then you can put keys here, which I'm going to switch here for a second because I have absolutely no idea where will it. Okay, I'm switching back. So yeah, you have to give it an IP, a port, a protocol, and the key file. So we'll have to provide this key file here, but I don't know yet which port is it, so I will have to figure it out. But I can see that there is like hello, certificate, whatever. Yeah, this is like 443, which is fine, and the IP is this IP, so I'm just going to note it. 172 31 20 2020 128 237. I'm assuming that there is one session here, but it's not a crazy task this time. This port is, it's connecting from 443. Wait, it's connecting to 443, obviously, from this IP, which is 57567. Okay, and so we probably have the decryption key for this SSL stream from the client. That's my guess. So let's go here, preferences, again, protocols. We again have to scroll to TLS. Where would you get the key? You basically would have to dump it from the memory of the browser. There are like, I think, like scripts to do it. Okay, I'm switching for a second to give it the key file from my drive. Oh, that's actually, I didn't have to switch, but that's fine. Okay, let's go back here. Now, IP address is I'm guessing this is going to be this address, and the port is going to be this one. It might be the other IP, which is expected here. And the protocol, I have no idea what's the protocol. What's the protocol? I don't know, is it like TLS? I don't know. I'm not going to put anything here. Let's see if it works. Okay. And I think this is... yeah, it's 443, so it actually decrypted it, as you can see, it decrypted it. And I'm going to do follow TLS streams, or HTTP stream, I guess. And what do we have here? We have a viewport, we have a website. There is nothing to see here. Okay, so that's one get. There's another stream, I guess, like even more streams. One stream. How many streams are there? So it gets this one, then it gets the CSS. So let's follow on this one, the HTTP. It actually like does it do all the... Okay, well, where's my flag? The flag was at the beginning of the stream. Okay, let's do it again. Sorry, it was 2 in that case here. You're saying I'm just like, I didn't notice it. Yeah, this is there. Yeah, sorry, I'm blind. Obviously, here. Yeah, I was looking in this, like, the content. So I think this task was actually an exercise in... that's incorrect? What do you mean it's incorrect? Oh, because of this wrong task. Yeah, cool. Yeah, it was an exercise in knowing where to put the key in Wireshark. This is something you can find in Google in 3.7 seconds or whatever, like in a couple of seconds basically. So there we have it. And the key was provided. On a real CTF, I guess the task would be more like, hey, this is like a memory dumped from a Windows machine or whatever, and with a browser running, and here's a pickup we have, and like, yeah, have fun, good luck. And then you have to extract the key from memory, like find it in the browser, extract it from memory, have it in a proper format, and pass it to Wireshark, then decrypt the protocol. So that's basically it. Yeah, 2 times I missed it. Yeah. Okay, is there anything we can solve in 10 minutes? No, I think we are just going to call it a day. So yeah, we did solve a couple of more challenges. We have one more unsolved one we started with. This is evil, like evil. Or like how, you know, we should write it, evil. This is how you write evil when you are coding in most languages. Yeah, but we did solve 6 tasks, so in around 1 or 2 years we should be finished with the CTF. I expect it to have like 600 challenges. I have no idea. Like, I know it's around 100, but yeah, we'll get there someday. So are there any questions? If not, then I guess we'll finish the day, and you can be off to hacking your stuff which you're currently working on. I can be off to hacking whatever I'm currently working on. Oh, check to see if the extra key you found in Droid. Okay, yeah, but that's an excellent October. That's an excellent tip. Let's do it because I would forget about it. So let's go to unsolved ones and the Droid. I got the extra flag when solving the Droid thingy, right? Due to my brute force. Where was that? Here we go. Perfect. So we used this one, I think. And we didn't use this one. Let's try to use the second one. To the Droid one here. No. And let's use this one. No. So that's not it. Is there another droid which we can try it? Maybe like it was a task with with 2 flags. We do not have another droid, I believe. Yeah. I'm going to try it again in case I like made a mistake with copy pasting. Nope. So no, I guess it might have been a task with 2 flags, or 1 flag is a red herring, like a fake, a troll. Okay, it was still good to check. Perfect. So I think that's it might get unlocked later. Yeah, that's true, Albert. I agree. The task might get unlocked later where the flag will actually work. So yeah, we'll see it. Cool. Are there any questions? If not, we can finish. I don't think there are any questions on the chat. I'm going to scroll a little up if I missed anything before. You missed all of my questions. Ido, hi Ido. Or Ido, I'm not really sure how to pronounce your name. As usual, I'm really terrible with names, I apologize for that. No, I don't think I missed any questions. Is it prohibited during the CTF to hack websites for answer submissions to steal answers? In general, yes. It has not been like that in the past. So it's like this. In several years ago, sometimes you even got additional points from the organizers if you hacked the website. And there was like Morse Mode Lead Chicken were pretty known for playing with CTF website and pretty frequently hacking it. Like I remember like on like one CTF final, suddenly we were pretty much on top, and then like MSLC just like goes up and up and up with scores and like just passes us through, I don't know, like 5 minutes time period, just submitting a flag after a flag after a flag. And it turned out that they figured out how to submit one flag multiple times. Yeah, like kudos to them. And I think like even a year before on that CTF, they also got some additional points for hacking the scoreboard. Now, in more modern CTFs, actually people added, like the organizers added, a rule which says you should not try or attempt to hack the website and you will get banned if you do that. So yeah, currently you should not do it. And I hope that the websites are more secure, but yeah, like, you know. Is there a police stream tomorrow? Yes, there will be a police stream tomorrow. Big thanks to moderator Gunvale for helping out with the stream. Yeah, Stoli, thank you for the moderator today for helping out. Perfect. Tomorrow there should be someone from my usual crew. If you missed them, I'm pretty sure you missed them. I missed them. So yeah, that's it. Thank you for being here today, everyone, and I see you next week. Probably we'll be again trying to hack picoCTF. Let's see how that goes. I want to finish all the challenges in that CTF, so let's see how that goes. Perfect. So thank you. Have a great evening, great day, whatever time zone you're in, or great night, I guess. And I'm going to leave you with some of the usual music.